Hi, today's topic is model-based software testing. In model-based testing, we use a model of a software system to help us systematically derive tests for that system. Models are widely used in engineering in general. As an example, the car industry uses physical models of cars to test a car's aerodynamic properties. The car tested is a simplification of a real car. It may not even have an engine, but it preserves the properties needed to analyze its aerodynamics. Well, these characteristics also hold for software models. First of all, a model is simpler than the original artifact, the full car. Second, the model preserves or approximates key attributes of the artifact, its shape. And third, the model can subsequently be used to analyze properties that can be translated back to the original artifact, in this case the aerodynamics. Well, in software we use models too. You may have, for example, used the UML, the Unified Modeling Language. It allows you to create models of your software, for example by means of class or package diagrams, which model the static structure of the software system. Well, for testing purposes, we are mostly interested in models of the behavior of software systems, that is, of the dynamic characteristics. In the UML, examples of such behavioral models include state machine diagrams and activity diagrams. In this course, we will take a closer look at two types of models. First of all, we will cover state machines. They can be used whenever a system maintains state, which, in fact, most systems do. A typical example is a web or mobile application which can be in various states. The transitions between those states and the events, clicks, swipes, inputs, triggering those transitions are easily modeled using a state machine. Our second type of model is the decision table. Decision tables can be used whenever combinations of multiple inputs determine a system's behavior. A typical example here are payment plans for mobile phones, in which a number of user choices determine the monthly subscription fee and the features you as a user can enjoy. Well, both types of models can typically be obtained from the system requirements or the user stories. In fact, they can help to better organize those requirements or user stories. For example, the marketing department at the telco will decide on the plans offered and can structure their plans using decision tables. Models obtained from requirements are typically meaningful to domain experts, and then developers can use them to identify test cases for behavior that must be there, specified in the requirements. Alternatively, models can be reverse engineered from the code base. In that case, the model reflects what is in the current code base. Such models are typically most meaningful to developers. And then developers can again use these models for their testing purposes. In this case, they will use the model to arrive at test cases that systematically exercise certain aspects reflected in the model of the code base. In the next few lectures, we will take a deeper look at model-based testing. In particular, you will learn, first, how to design, create, derive models, in particular state machines and decision tables. And second, how to use these models, once created, to systematically derive tests and to reason about the adequacy of such tests. Enjoy!